Building linear models from data. So look at this problem down below here. It says using a scatter plot to investigate cricket chirps. It says table 1, which is here, shows the number of cricket chirps in 15 seconds for several different air temperatures in degrees Fahrenheit. Plot this data and determine whether the data appears to be linearly related. So we're going to have to do a linear approximation here. Actually, we're just going to have to look at the scatter plot to determine that. But we're also going to do a linear regression for this problem also. So this is all calculator stuff. So break out your fancy calculators. You need TI-84s, TI-83s, TI-82s. Those would all be sufficient for this video. Okay, so we got the chirps up top and the temperatures down below. So we're going to call this our X and this our Y. And essentially, we're just going to plug this data in our calculators, and it's going to do all the work for us. So that's the idea for these. So first things first, break out your calculators. Here we are. So the first thing I want you to do is I want you to click on Stat, which is right here, after you turn them on. And once you click on Stat there, I want you to click on Edit, which is the first one. And it's already set up for that, so you can just press Enter. And once you press Enter there, you'll see this screen show up. Now, it won't have all the data in there, but it'll be the screen. And you can get right in this first spot here if you're not already. I think you are initially. And you could do this by using these buttons here, the scrolling buttons. Now, one thing I like to do is right away, if I have stuff in there already, I'll hit the up arrow here, and that'll put me up top. And then if I type in, or if I push the clear button and then enter, it'll wipe them all away, which is very handy to wipe a list out, because sometimes the list that is pre-existing is longer, so then I got to delete the rest after that. So that's generally why I do that. So anyways, let's move on. So you got to put all the data in here. Okay, now notice, this first column is my X and the second column is my Y. So there's my numbers. So you see the 44, 44, and then I just ran through all of those. And when you push Enter, you go down to the next one, you fill it all in. So now once I put all that information in, you can see that I have it for both lists. Then I'll tell you what I do next. Then I press the Y equals, which is here. And when I press the Y equals, it brings up this screen here. And then what I do from this screen is I scroll up, and it puts me up top here, and it'll be blinking there. And what I have to do when I scroll up there, I have to push Enter. And then when I move back downwards using the down key here, it'll stay bolded that way. It'll stay black around it. And that tells you that the plot is selected, because we need the plot in order to do this. And then the next thing after I do the plot is I go to Zoom. And when I go to Zoom, I scroll all the way down to Zoom Stat. That's number 9. It may be a little different depending on the calculator you have. And then once I'm done with the Zoom Stat, I just go to Graph. And then I see this. Because the Zoom Stat sets it up in the right window, so it should include all my data points. And that's what this is here. And the question was, if you remember, it asked the question, plot this data and determine whether the data appears to be linearly related. So then when I go back to that last screen, this is what I see. Does that look like a line? Now, it's not going to be exactly a line there, because there's definitely outliers in everything, especially in real life. Nothing's perfect. But you can see that, hey, that looks like that can be a pretty nice line in there to predict these data points. And it does look pretty linear. I would say it is, and I would write that. So that's the idea of this video here. Now remember, all we really did here was a scatter plot. Okay, and we looked at the scatter plot to say, hey, is this, does it look like a linear relationship? Now let's go a little further. Let's actually find the line of best fit. And that's what we're going to do now. So scatter plot. Okay, let's do the next one now. Okay, here it is. Now what we're going to do is we're going to find a line of best fit. Okay, you might hear those words. Find the line that best fits this data, or find the line of best fit. And that's what we're gonna do now. So take a look at this. So it's like I'm starting completely over again. Okay, so I click the stat button, and then I click on edit. I push enter. I make sure I'm bolded on that, and then I push enter. And then what I do is I plug in all my data, and that's what we do here. So if you already have that in there, great. You can skip these first few steps. And then what I do is I go back to my main screen here, and to do that, I pushed enter and then the mode button, because if you look above the mode button, it says quit, because I have to get to the main screen so that I can calculate. If you have anything there, it doesn't matter if there's something there. You could add stuff like calculations you did previously, and that's fine. You can leave it there. You just need to be in this screen in order to do what we're going to do next. So then what I do is I click on stat again, and it's going to put me here, and I scroll over to calc. So I scroll to the right one, and you see when that calc pops up, which is over here, when that calc pops up, I scroll down to linear reg, or linreg, AX plus B. And that's the one I pick. It's number 4 on this one, but it might be a little different on yours. So then once I see that and scroll down to it, make sure it's bolded on it, I push enter. And then when I do, this is the screen that comes up right away when I do that. Yours might not. Yours might blink this and give an answer, and that's okay. But if it doesn't, this is kind of nice too, because it says L1, L2. It gives you an option to change those if you needed to. You shouldn't have to. I wouldn't worry about that with this class, how quickly it is. And I have to push enter, 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 enter like 4 or 5 times here. And then I get to the next screen when I do that, which is this. Your calculator might give you this right away, which is fine. That's okay either way. Now this is actually the answer to the best fit line. Now notice what this says. This says y equals ax plus b. So if I was going to actually write that line, I would say y equals, and let's say they said to the nearest hundredth to round it to. Now they don't always tell you that, but let's say they did. And my a looks like that's going to be my slope. So then that's going to be my 1.14x, because remember, my equation of a line is y equals mx plus b, and that's what that a and b are representing. And this would be plus 30.28. That's what I would actually write if it said round to the nearest hundredth, my answer, and that's the best fit line of what it would be. Okay, but we're going to go further than this. We're going to graph it and put it all together. We're going to see it all together on this calculator. But that's what it would be if that was my answer. If that's what it was looking for, the line of best fit, that would be the answer. But anyways, we're going to go further. We're going to graph it. So now after I see this data pop in, it's actually stored on the calculator. So now what I'm going to do is I'm going to the y equals screen again, and this is what pops up once I do. And then make sure my plot's on, so I scroll up, bold the plot. By doing that, I push enter. If it's clear like this here, where you don't see a sign on it there, I just scroll up, and then once it's up there blinking, I push enter, and then it stays bold like that in this screen. Okay, so now what we're going to do is we're going to put the equation in there. Now again, when you type these equations in, you have to put all the numbers in there. If you miss a number, it's going to throw it off a little. So the best thing to do is to cut and paste it in. So what I do once that's bolded, I scroll down one, and I'm sitting right here. My cursor's just blinking on that first one. That's what's happening. It's blinking right there. Or it might be next to it. But anyways, I want to be in that first slot there. And then once I'm in this first slot I mean right here. Once I'm in there, I click the variable button, the vars key, and that means variables. And then if you go down to 5, notice what 5 says, stats. And since we're dealing in stats, that's where it's stored. It actually stores it only while it's still up there. If I do another one, it erases it. So I got to make sure I do it right away. So once I click on the stats, I go to the right to EQ. So I'm going to have to use this side key twice, hit it twice. And that gets me over there. And then you see the first thing there says reg EQ. That means regression equation. And I click enter on that. And what happens is it pastes it right in there for me. That's what the nice thing is. Because I don't want to have to type all that in, and I won't remember that. I'll have to go back and forth so many different times in order to do that. So that's what I click. I click enter, and then I go to my zoom button, which is here, and then I go down to zoom stat again, scroll down to it, and then when I graph it, notice this. This is kind of nice because it gives me all those data points still, but now it actually puts the line in there. Now, the reason why I want to put the line in there sometimes because later on I might ask, which is a better fit? Is this quadratic or linear, or we could do logistic or exponential or logarithmic? And one of those might be better, so you'll have to be able to go through this process to evaluate which one is the best choice. Now, they would all give their best choices depending on the function that I had, but some functions might be better to use like an exponential for or a logistic. So those are ones we haven't talked about yet, but we'll get into. But again, that's the setup of how to use the calculator for linear models.